Hi, my name's David Rowe. I'd like to talk about my project called Democratising HF Radio.
HF radio is very useful for communicating when there's no infrastructure. For example, if you're in the developing world, a long way from where the mobile phone or internet networks are, or if you're in a disaster situation, or perhaps a country where the government's cut off your communication. It can operate over hundreds to thousands of kilometres and send data at messaging type bandwidth, so SMS and emails. Problem is it's very expensive and it uses complex, not well understood technology. I'd like to make it available to everyone. I believe this can be done by using open hardware and open software, and we can drop the cost of HF radio from around $10,000 per site to a few $100s per site. The initial goal is messaging over lengths of around 100 kilometres, so that means texts or small emails over lengths of 100 kilometres with no infrastructure whatsoever. I'd like to publish the designs, the hardware designs and all the instructions on using the software, and actually encourage the pirating of the hardware to manufacture at lower cost than what's currently available at the moment. I'd also like to experiment with the idea of local manufacture. Now this could be final assembly or setup and flashing, or it could be actual soldering, actual real world assembly from components of these radios. By local people in the developing world. One of the problems with operating in the developing world is the supply chain. People there are just sick of expensive first world technology that arrives, works for a while, breaks, can't be repaired, no one understands it, and is so expensive compared to their local incomes and the money they have available that it's really impossible to deploy at volume. The supply chain is a huge problem, and fixes for the developing world are just not about technology. They're often more about the supply chain and training than they are about the wonderful first world technology we take for granted here. An example is in Tanzania, where it can take 8 weeks to clear customs. Some colleagues of mine are deploying HF radio networks for medical applications there and have to wait 8 weeks for anything to get in the country. In East Timor, where I've worked with the Village Telco project, they have very high courier costs. The people there can least afford it. They're some of the poorest in the world, but they have to pay more for the shipping than the actual hardware in many cases. Once it gets there, you could be talking a few days over bumpy roads to get it to where it's got to go and be installed. So you better make sure you brought everything with you that you need. Other issues include theft, unreliable mail, government interference, several days' walk, where you want to go may not have roads associated with it, and the proportional cost. The hardware might cost, say, thousands of dollars or thousands of man-years of income for a local person, just so much more than the sort of money we're associated with paying for technology. And then there's issues of local repair and maintenance. If you can't repair and maintain the thing locally, the supply chain works against you in reverse to get it back to anywhere where it can be repaired in the first world. Okay, so can we build simple HF radio technology ourselves? Well, yesterday in about an hour and a half I built up this simple radio using parts I had layering around. I did it with simple tools, nothing particularly specialised there. It looks a bit complicated, but I'm pretty sure I could teach anyone to build this. I've already had friends involved with this sort of work that haven't been as highly skilled as I, and we brought them up to speed very quickly. So not hard to assemble by anyone. But as you'll see in a minute, a fully functional radio capable of sending messages over very long distances. So the sort of parts I used were the sort of parts you could find in old TVs and PC power supplies. We combined that radio with free and open software that runs on a laptop, or it could run on a reflashed router, or even a smartphone. The software does most of the functionality these days in radios. The hardware is very simple, which means it's easy to build or very low cost. Now the software can be free, which means the entire radio can be very low cost. And being free software, it's possible to teach people how it works, and anyone can understand it, modify, reuse it, which is very important as well. What I'd like to do would be to develop tools and systems to test, train and debug this sort of hardware, so as well as the actual instructions on how to build the radio, how to build all that support infrastructure you need to make sure the systems are working correctly, and to work out how it can be fixed when something goes wrong and the first world guy isn't around anymore. I believe we can make it very easy to set up and use. Emails will just turn up in a local email server after their journey of hundreds of kilometres. The example I'll give you in a moment uses scripts, but I just knocked that up in half an hour on my PC. That'll be replaced in a GUI in the final system. And I'll demonstrate it to you sending a message over a radio link and receiving that message. Now I'll just have to switch off my audio for a moment, as it'll be going, the audio will be used for the actual radio, and you may actually hear the modem tones coming through the radio. Okay. Okay, so you should have my audio back again now. So what you can see down the bottom is that message between start and end. Hi honey, I'm walking home from setting up this HF radio link and should be home in about 8 days. Don't wait up. That was sent over the little radio hardware that I just showed you a moment ago. And that was all running free and open source software. Oh, excuse me, just had a message. That's one of my colleagues who's working on that project with me. Okay, so now that used all open source software. It's a real live operating system. This is not vaporware. This is not future technology. This works today at sending and receiving messages. Still plenty of work to do, of course, to get it into the real world, but this is all really possible stuff, and I've just sort of showed the basics of the system operating in front of us. Here's some training I did a few years ago in the developing world. This is people in East Timor doing final assembly of meshed potatoes. The boards were manufactured in China, the printed circuit boards. However, we then put them inside a box, wired up cables, wired up power supply cables. So the various aspects of the assembly were done by the local guys, and they loved it. It was one of the most popular parts of the project. The empowerment they got from actually doing local manufacture rather than buying things and importing expensive first world technology was just great to see, and it's what's given me such enthusiasm about this local assembly idea. A big part of this project is education. Local people being empowered to build their own radio networks. Now the low cost and local repair will result in much wider use. Many more people will get connected. There's currently 1 billion or more who aren't connected in any way with electronic telecommunications, and this will help those people get connected. Local industries will spring up, such as the email wallah. In India they have the chai wallah and the water wallah, the man who does certain tasks. This will, start self-employed people turning up in villages and saying, here, would you like some email? I can provide that for you using this sort of technology. Low cost means backup and reliability. A village can have 2 or 3 of these systems set up. So if one dies, you're not losing a $10,000 investment, it's a couple of $100 investment instead, and you can afford to have backups. That'll make it more reliable. And the empowerment of this knowledge being transferred to local people cannot be underestimated. And finally, this is a slide of some of the people that we trained in East Timor. Within half a day, we had them trained to install meshed potatoes. They then went on to train other people, and 2nd and 3rd generation training happened. So I've got some experience in this, and it's given me some ideas to push the ideas a little further. Thank you very much, and I hope you'll consider my application.